Alright, so the last time I did a video, I did the same lesson and we were talking about the same topic, which is dividing fractions. However, now we're going to do the algorithm, or we're just going to do the math behind it. And so the way you would actually say to divide fractions, if I had 1/2 and I'm dividing it by 7/3, I would need to multiply by the reciprocal. And what that means is I need to change this to multiplication and I need to flip the second fraction. What we talk about with our students is that we need to freeze, change, flip. And that's just a quick and easy way to remember how to divide fractions. So we freeze the first fraction, or it remains the same. We change division to multiplication, so we simply just change the sign. And then we flip or take the reciprocal of 7/3. So 7/3 becomes just the opposite of that, which is 3/7. One big part of dividing or even multiplying fractions, because that's what we turn it into, is to look to simplify before you multiply straight across. If you have something that you can simplify, like we will in a minute, it's important to do that, because otherwise your numbers get so big at the end that it's hard to come up with the factors, and it just takes a much longer. All right. I don't share any common factors with the numerator and denominator. For example, a lot of times we look at diagonals, and 7 and 1 only share one factor, which is 1. So we really can't make this any smaller, and the same thing for 2 and 3. There's nothing we can divide them both by to simplify it. So we simply multiply straight across. 1 times 3 is 3, and 2 times 7 is 14. So the big thing with division is we just change it to multiplication by freeze, change, flip. Looking at the next example, and the kids have some math maps in the back of their packet, and I have one as well. If you look at the guided notes and you look through them, at the very end I have these math maps that say specifically how to turn a mixed number into an improper fraction, or an improper fraction into a mixed number. So this one wants me to take 3/4 and divide it by 1 1/2. The problem with 1 1/2 is you can't divide a mixed number. So I need to MAC is what we call it. We multiply and then add. So we multiply the denominator times the whole number. 2 times 1 is 2. Then we add our numerator and we get 3. And the K stands for keep. We keep our denominator. And I'm going to bring everything else down. I think that it's important to not try to turn this improper and freeze, change, flip in the same step. I find that kids make mistakes. They often forget to actually flip it. So I try to do it in 2 separate steps. Now I have 2 fractions, no mixed numbers, and I'm ready to freeze. I'm keeping this the same, and it's always in that order. We freeze our first fraction, change division to multiplication, and flip our next one. And this one's a really good example of how to simplify. So what I do typically is I look for my diagonals, and I look at 3 and 3, and I ask myself, what factor do they share other than 1? Because 1's not, if we divide by 1, we're still going to get the same thing. But if I take 3 and I divide them both by 3, I'm going to make it smaller. And when I multiply, it's going to be easier to handle. 3 divided by 3 is 1. I like to cross it out and put my new number on the outside. 3 divided by 3 is 1. And then I look at my other diagonal, and I notice I have a 2 and a 4. And I know that 2 and 4 can both be divided by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then I'm going to rewrite my new fractions. And then I'm going to go ahead and do the multiplication. So I have 1/2 times 1/1. So it's much simpler. I could have handled it even without the simplifying, but there are examples that it's a little bit trickier if you try to simplify later on down the road. Kids are pretty good at finding the factors of 3 and 2 and 4. It's a little harder for some of the other ones. All right. Let's take a look at, this will be the last one that I go over. They all pretty much work the same. This one has 2 mixed numbers. So we're going to follow the same process that we did before. We have to first MAC both of these. We're going to multiply, add, and keep our denominator. So I take 5 and I multiply it by 2. 5 times 2 is 10. I keep that number in my head. I don't write it down. I add 3 more and I end up with 13, and I keep my denominator. Notice that I'm still in division. I'm not going to try to do 2 things at once. And I mac this one as well. I multiply first, 9 times 1, keep it in my head. Then I take that 9 and I add my 8. 9 plus 8 is 17. And I keep my denominator. Now that I have 2 fractions, I'm ready to freeze, change, flip. So I freeze or keep my first number. I change my division to multiplication, and I flip or take the reciprocal of 17 over 9, so it becomes 9 over 17. I'm looking for common factors, and so I look at 5 and 9. You can even do it within the same fraction, as long as you choose a number from the top and a number from the bottom, and you divide them by the exact same thing. So in math, whatever you do to one part, you got to do the same thing to the other. I really don't see anything. I'm looking at 13 and 17. They're prime. 13 doesn't go into 17. It's not going to work. Same thing for 5 and 9. So I'm ready to multiply straight across. So 13 times 9. 9 times 3 is 27. 9 times 1 is 9 plus 2 is 11. So I get 117. When I look at my denominator, I'm going to take 16 times 5. Sorry, 17 times 5. 7 times 5 is 35. 5 times 1 is 5, plus 3 is 8. So I have 117 over 85. This is an improper fraction somewhere in one of the elementary schools. I kind of like the saying that one of the teachers says, and they say the elephant sitting on the chicken. And this looks strange because you have your bigger number, or the elephant, sitting on your smaller number, the chicken. And when we have that, we need to turn it into a mixed number. It seems kind of silly. We have to turn it from a mixed number to improper. We do the math, and then for our final answer, again, we're supposed to go back to a mixed number. Again, this isn't a math map. It's something that was taught in elementary school. But all you're really doing, it's saying 117 divided by 85. 117 divided by 85. And I know 85 doesn't go into 1 or 11. And I'm doubling 85 in my head, and it's 170. So it's not going to go more than once. It's just going to go exactly, or it's going to go one time. I multiply 1 times 85 and get 85. And I subtract. I can take away 5 from 7 and I get 2. And 11 take away 8 is 3. The last thing we do, we call this the ring of fire. We just kind of made that up. But we go in this order to write our final answer. We start with our 1, and our 1 is my whole number, my big number. My remainder, we don't use the R word anymore, but my remainder, what we used to call a remainder, actually becomes my numerator, and my denominator stays the same. It was 85, it stays 85, but if we follow the ring of fire, it's where our ring ends. So our final answer would be 1 and 32/85. So hopefully those are some good examples that will help lead you in the right direction.